Hi everyone, welcome back to my channel Explore with Aditi Vyas. In today's video, I'm going to discuss about study of compounds hydrogen chloride, chapter number 8, your ICSE class 10th topic. Alright, in this video, I'm going to provide you handwritten notes of this chapter. But before that, if you are new to my channel, please subscribe to it and watch video till end. If you like, then share it with your friends. Okay, so let's start. Firstly, we are going to discuss about hydrogen chloride. If we talk about its molecular formula, then the molecular formula is HCl and molecular mass is 36.5. The bond between the HCl is covalent bond, and we all know that covalent bond is formed by the equally sharing of electrons. Okay, so in case of dot structure, we can clearly see that there is one electron of hydrogen and one electron of chlorine, and then they form a covalent bond, and then the formation of hydrogen chloride take place. All right, and if we talk about the orbital diagram, you can clearly see that the orbit of hydrogen is small in size as compared to chlorine, because chlorine has a more electron than hydrogen, but these two elements share one electron, their one electron with each other and form covalent bond. Okay, so the next one is its occurrence. If we talk about its occurrence, firstly we have to discuss about hydrochloric acid, and Globular prepared the acid in 1648. Okay, Glover prepared this acid by using NaCl, that is your sodium chloride, with the concentrated H2SO4 by providing it proper heating. Okay, and Lavoisier named it muriatic acid. Okay, but in 1010 यानी कि 1810 Dewey named it as HCl, that is hydrochloric acid. Okay, so you have to know these scientists' name. These three are important according to your ICSE book. Okay, so HCl gas occurs in free state in volcanic emission. Whenever the volcanic emission take place, then HCl gas is produced. All right, and it is also present in mammals. Okay, as a gastric juice which help in digestion. Then come to the general properties of HCl gas. Make sure that you will not be confused between the HCl gas and HCl acid. Here we are going to discuss the general preparation of HCl gas and not HCl acid. Okay, so by synthesis, or we can say direct combination of hydrogen and chlorine, these both are gases, and they can directly combine in the presence of diffuse sunlight, which leads to the formation of 2 HCl, which means HCl gas. But here the important point is the reaction is so explosive when it is take place in direct sunlight, but it doesn't take place properly in dark. But if some catalysts are present, such as activated carbon, the reaction take place in dark. Okay, so we all know that catalyst increase the activity of our reaction, and here catalyst also play important role. Okay, so second one is by heating metallic chloride with concentrated H2SO4, or we can say sulfuric acid. Okay, which means we are reacting the metal chloride with concentrated H2SO4 and giving them proper heat. So here is the formation of a salt plus HCl gas that we need. Okay, after that, lab preparation of hydrogen chloride gas, which is very important. Okay, so the reactant is sodium chloride and concentrated sulfuric acid, and the reaction is NaCl, which is sodium chloride, concentrated H2SO4, but the temperature is below 200 degrees Celsius or 200 degrees Celsius, which leads to the formation of sodium hydrogen sulfate plus HCl, which is your gas. If you want these handwritten notes, then you can mail me, I will send you. But here's the one question arise during the lab preparation of hydrochloric acid or hydrogen chloride gas, that is why temperature is below 200 degrees Celsius or 200 degrees Celsius. Means why temperature is not to be more than 200 degrees Celsius. The reason is If the temperature is more than 200 degrees Celsius, then the reaction will change and the sodium sulfate formed instead of sodium hydrogen sulfate, which is hard crust substance and stick to the surface of glass. All right. And the second one is glass apparatus may crack, okay, because of increase in temperature. And if we can do this if we can do this reaction in the presence of 200 degrees Celsius or less than 200 degrees Celsius, then why we are going to waste our fuel? Okay. So these are three important reasons. Then the next question arise through this reaction is why nitric acid is not used in lab preparation of HCl. Okay. So the reason is nitric acid is volatile. Okay, we all know the important property of our sulfuric acid, that is it is non-volatile in nature. So nitric acid is a volatile acid and it may volatilize out along with hydrogen chloride. Okay. So we cannot differentiate the HCl gas and nitric acid, okay, because they both can volatile. Then how to dry HCl gas, because we all know that HCl contains some vapors, okay. Then how we can dry this gas? So pass HCl gas through concentrated H2SO4. When we are going to pass this gas through concentrated H2SO4, it will become dry. Okay. As you see, the reaction will take place in the presence of concentrated H2SO4, but when this HCl is produced, this HCl again passed with H2SO4. Okay. And we have two type of agents. Then one is dehydrating agent and the second one is drying agent. Here we are using H2SO4 as drying agent and not dehydrating agent. The reason is drying agent remove water vapors while dehydrating agent remove water molecules. Okay. So here we have to remove these water vapors that are present in HCl gas. So we are using this concentrated H2SO4 as drying agent. Then the next question arises, that is why we cannot use quicklime, okay, as drying agent. We all know that quicklime is also a good drying agent. Then why we are not using it? The reason it quicklime is a base and we all know neutralization reaction. So when base and acid react, it will form salt and water and it will not going to dry the HCl gas. Instead of that, it will lead to the formation of salt. So H2SO4 is used, which is acidic in nature and it is not going to form salt. Okay. Then come to the properties of HCl gas. Very, very important. Here we are going to discuss the fountain experiment, which play very important role in your syllabus. If I talk about the properties of HCl gas, it will not change the litmus paper and it is acidic in nature, pungent smell and sour in taste, of course, and it is colorless. But the main property is highly solubility in water. HCl gas is highly soluble in water and it can be explained or proved by fountain experiment. You can clearly see here I am prepare the apparatus or here I am draw this experiment. Okay. We are using the dropper in which we add some water and in the beaker we add blue litmus solution plus water, and here we are using a jet tube and then the red fountain occur. HCl gas fuel is contained in this beaker. Okay. So whenever we squeeze the dropper, okay, whenever we are going to squeeze this dropper which contain water, so water vessel enter in this flask. Okay. In this flask water vapor get enters and vessel have HCl gas. We all know that this vessel contain HCl gas and this HCl gas is dissolved in this water. Okay. And when this HCl gas dissolved in water, then there is some vacuum in vessel. Okay. Right. Because we all know that gases contain allows area, but whenever we add the water, then it will gives too much vacuum in the vessel, and so pressure falls. So atmospheric pressure from blue litmus to rise upward jet tube, and the atmospheric pressure in this blue litmus solution rise upward the jet tube. Through this jet tube it enter to this vessel, and because HCl is acidic in nature, here the red fountain occur, and this blue litmus will turn into red, and it will prove that HCl is highly soluble in water, as well as HCl is acidic in nature. Okay. Then the next important thing is test for HCl gas. Whenever we are going to test for it, we are using ammonia, and it will give you dense white fumes. All right. Then we are going to talk about HCl acid. Okay, so we can use inverted funnel arrangement here, because we are generating the HCl gas. Look here, we have a beaker and we have water in it, but rate of dissolving is more than rate of generating. Okay, we are already discussed that HCl gas is highly soluble in water, so the rate of dissolving is more than generating, and it will lead to the wax suction. Okay, to prevent this wax suction, we are using inverted funnel arrangement. Okay, and this will provide you larger surface area and prevent wax suction. Okay, then come to the properties. So if we going to discuss about the properties of HCl acid, not HCl gas, so of course it will turn litmus into blue into red, acidic in nature. In aqueous it will give H positive ion, and it will convert methyl orange into pink in color. Then reaction with metals, it will give you the reaction with metal and lead to the formation of salt plus hydrogen gas. Whenever it will show reaction with base, because it is acid, it is show neutralization reaction. Here it lead to the formation of salt plus water. And in case of reaction with metal carbonate, it will form salt plus water and carbon dioxide. In case of sulfite, it will lead to the formation of sulfur dioxide, and in case of sulfites, it will lead to the formation of H2S gas. But the most important reaction is reaction with thiosulfate, where it will form yellow sulfur. Okay, and in case of nitrates, it will form AgCl or PbCl2, which are white precipitate. Okay, video is going to be so long, that's why I'm not going to discuss this reaction in details. And then the next one is formation of aquaresia. Very very important. What is aquaresia? So this is 3:1, and here's the ratio of 3 is HCl and 1 ratio of HNO3. This aquaresia lead to the formation of nitrosyl chloride and nascent chlorine, and this nascent chlorine will react with noble metals. Okay, lead to the formation of metal chloride. Then come to the general uses of HCl acid. It is used in lab as reagent, and it will definitely lead to preparation of aquaresia, used in industries, used in medicine. So this is all about your chapter number 8, that is study of compound hydrogen chloride. I hope you all understand it. Thank you for watching.